In this video, I will let you know additional part that needs to be set up in order not to make communication error for CAN AUTOSAR. Set using ECU configuration in AUTOSAR 1.2.3.2. There are parts that need to be manually modified, so split the file to create and modify another file. Create a file by following the same path as the video, paying attention to the file name. Next, the bus address of the CAN controller should be modified within the CAN config set. It matches the base address that was adjusted in the Macau module 428,662,016. The following matches the boundary to config in the controller, the same as when setting up the CAN module. Next, the CAN FD boundary config is also matched with the same parameters as those from Macau CAN module. And make sure that the HO filter code, which corresponds to RX, matches the value set among the mailbox made. After BSW code generation, I will explain how to delete the comments that come out. After generating the BSW code, I will delete the comments that need to be deleted into the Python code. The Python file named remove integration macro, which exists in the build folder of the project, handles the comments that need to be deleted as shown in the following video. If you are not using it as a project under the name of RTA base, but under another name, you should change the name of the project that corresponds to macro in the following video. After that, if you run the Python file in terminal, the set comments will be deleted. Enter the AUTOSAR environment and generate the required memap files. Run the AUTOSAR code generator and run memapgin as follows. Among the memap files created within the project, the following 5 files are deleted. If you use the RTA base project, you can build it right away, but if you use a project with a different name, you need to change some file paths within the script folder. Check the gent.make Python code and toolchain-tasking.make code as follows. If the previous processes are completed, you can run the build batch file in the build folder. Over time, you can see that the build is completed as follows, and the ELF file is created in the output folder. If you check the runable function code that is executed to check CAN communication, you can see that TX and RX communication can be performed using the variable of the write name and the variable of the read name as follows. Let's flash using trace 30 to debug equipment and check CAN communication using Buzzmaster tool. It should be connected to the ES58 driver as follows, but the Buzzmaster marks it as 582.1, so you can select it with caution. Since CAN channel 1 is used, you can proceed with the configuration according to the channel, and make sure that the baud rate is also consistent with the set CAN module. If the Connect button is pressed to remain connected and the board is operated in the running state at T32, the Buzzmaster will receive the RX signal. As shown in the message window, it can be confirmed that the 4 and 3 set as the write variable are being sent normally. Click Transmit window to set the message to send from Buzzmaster to TX. Set message ID, data length, repetition, and write down the value you want to send as desired by the user. In Buzzmaster, you can see that messages are being sent in TX type. If you look at the AUTOSAR buffer value that receives RX, you can see signals in AUTOSAR X00000 and AUTOSAR X00001, respectively, as you can see in the code. If you check the value for the corresponding buffer in T3 too, you will be able to check the signal value sent by Buzzmaster.